Hello and welcome to this Oracle database world. You have a machine learning model. Now what? Streamline model deployment with Oracle Machine Learning and Autonomous Database. My name is Marco Sarancibia, Senior Principal Product Manager of Machine Learning. And today we're going to have a great session all based on the Oracle Machine Learning capabilities for deploying models. We're going to start with a quick overview of Oracle Machine Learning, information about algorithms. So we're going to then move to model deployment options. So how to deploy the models with PL SQL, and also load the models with SQL, deploy them with SQL and load them with Python, and vice versa. And then we're going to move into Automl Ui, where we're going to learn how to deploy the model 3 different ways. And finally, we're going to finish with Oml Models, where we're going to deploy models. And then at the end of the session, we're going to actually be scoring those models using Oml Services. So a quick overview of Oracle Machine Learning. So Oracle Machine Learning is a family of products. Basically, the first components we have are the 3 interfaces to the most popular languages for machine learning, SQL, Python, and R. Then we have the Oracle Machine Learning notebooks, which actually are notebooks based on Apache Zeppelin, very useful and most frequently used by machine learning data scientists nowadays. Then we have Oracle Data Miner, which is a UI that we built for a workflow approach for desktop use. And then we have the Oracle Machine Learning for Spark, which is a tool that runs machine learning inside big data clusters under Spark. And then we have Automl Ui, which allows you to build models with a click of a mouse and then deploy them without having to type any code. And at the end, we have the Oracle Machine Learning Services, which is actually our platform for deploying real-time scoring models. In essence, what we have is 3 key pillars, right, for Oracle Machine Learning. We have automation, we have the scalability of those models, and then we have the capability of deploying those models very fast. And that's what we're going to study today. So here is a long list of all of the models that actually are right now in database running inside Oracle Machine Learning. And we don't want to hang up on all of this list, so I'm not going to give you all of the details on those models, but we're going to actually be showing you some code to run some of these models and then score them. So for model deployment with Oracle Machine Learning using SQL, building the models in SQL and then deploying them in SQL as well, we have something like this. So the data scientist is going to be working with SQL. He's going to be accessing or loading data from an analytical base table, right? A table that was worked with between him and data engineers, and now you got that table that is the one that, final table for you to work with. So once you have that, you can run that SQL directly against that table, and then you can generate basically all the capabilities needed by your application developer, which actually is just waiting for those capabilities to deploy them into the applications. As well as the Oracle Analytics Cloud, which can actually access natively the models in database and then run and score them. So for example, on the left-hand side here, I have a construction or a creation of a model using PL SQL. And you're going to notice that basically highlighted in red is the name of that model. So I'm using at the top, making sure that that model does not exist, right? So I have to delete it if it does. But then when I create that model, I basically name that model, right? I have that specific name, and that model is going to be stored in the database with that name. So on the right-hand side now, I have a SQL call. So with that, I'm just scoring that model using the same name. This time I'm using just plain Oracle SQL, but this is a special Oracle SQL because we have the prediction underscore probability function running there. And we also have a prediction function. So these 2 functions are specialized Oracle SQL functions that are running in database and are capable of running that scoring for us directly. So at this point, you can see we have both the same name on both sides to make sure that we're using the same model and the right one. So this SQL code, together with Python code, can be run in our Oracle Machine Learning notebooks in Autonomous Database. So in that case, we have the platform which allows you to use both languages. It's an easy way to share, document your process, and projects. We have permissions, we have versionings, and so that the idea there is the data scientist is really at ease on all of that language and can exchange and switch information between when you run in SQL, whatever you run in Python, as we can see in the next section. So now we want to build a model in SQL, but we want to score that using Python. So basically what Oracle did is on the machine learning component that we have, we created a Python interface and an R interface. So the Python interface and the R interface uses basically the database as a large, high performance compute platform. So we can launch processes in batch, we can launch processes in parallel, we can take advantage of the memory computation that the database provides, and we can take advantage of all the functions. So transparently, if you're trying to compute a count or a mean or a sum using Python or R, instead let the database do the work and then just get you the result. So on top of that, what we do is we allow you to actually use your own R and Python code as well. But in particular, the Oracle Machine Learning for Python has additional capabilities, which are the automated machine learning, or AutoML, and the MLX, the model explainability. So those are capabilities that right now run only on the Python component. But the idea then is the same, right? So the data scientists might be using SQL and will be using Python, both using the notebooks, same access to that table. And now, again, the app developer is the same way. He's accessing the results coming from the data scientist, and the Oracle Analytics Cloud also can access those models. So to go back and compare with what we were doing before, on the left-hand side, we have a PL SQL model building. Again, the same model, exactly the same code we had before. But now on the right, we have Python code. So that Python is, we're basically loading the Oracle Machine Learning Python package with an import OML. Then we're going to create a proxy into the database table so that we don't bring the table into Python, we just point to it, right? And then we're going to load the model. So when you say the model is a decision tree and you give it the model name, it's actually going to load the existing decision tree model from the database into memory. So now I can use score with that model. So that one line of scoring, I can do a model.predict underscore proba, and then that model is basically scoring that line is basically scoring the model for me. And you can see now that basically having the same name is what makes this work, right? So you have that same name on one side, you have the same name on the other, and it works. So now we can actually do the opposite as well. So in this case, we can build a model in Python and we can actually score it in SQL. So on the left-hand side now, I have my data scientist actually loading the OML package, and then he's running that, synchronizing a table, and then he's actually doing the entire model build. In this case, he's going to build a random forest model. So as an example here, we have the settings, and then we have the model fit. So he does a dot fit. But more importantly, he actually does a model underscore name. So whenever you do that in OML for Pi with the model underscore name, that means that you want to store that model permanently on the database with that name. So on the right hand side, I have the SQL code. Same SQL code again, prediction underscore probability, but as long as I call the model by the right name, I can just use that SQL to score the model immediately. As soon as the Python code finishes running, I can then start coding that model and calling it from SQL. As simple as that. Now moving to Automl Ui. So Oracle Machine Learning built the Automl UI for really making sure that you don't necessarily need to code, right, to work with this. And there are other sessions that you might see about the complete Automl UI that I suggest you guys to take a look at. So the specific component on Automl UI basically allows you to do automated algorithm selection, adaptive sampling, automated feature selection, and automated model tuning. So these 4 components actually are executed by the UI, without any user intervention at that point. So you only enter basic settings, and then at the end comes a model. And that model is the best model possible with that amount of time that you gave it to run. And basically, then you can see that it is a UI. It is completely free of code, but it does allow you to enter several options and capabilities, and then it actually has results. Nice results showing, the weights of the models using the model explainability capabilities, and shows you the confusion matrix and things along those lines. So it requires really minimal user input, but it does give you a leaderboard of models, and it shows you the best metrics that each model has, so you can choose and compare models. And then we have another interface, which is the Oml Models, which not only allows you to check models that are currently in database, but also allows you to deploy the models and verify the deployments. So in this case, if a data scientist uses the Oml Automl Ui, what he's doing now is he has several different options. He can generate a notebook, and that notebook is an auto-generated notebook that's going to have the entire model settings in there. So he's going to be able to, again, do SQL scoring out of there, or export the model into Oml Services to deploy it. He can deploy the model directly from Automl Ui, and he can also deploy the model directly by renaming the model into a SQL model. So at that point, the application developer can just use SQL, and Oracle Analytics Cloud, for example, can access natively the models right there. So let's take a look at the deployment by renaming the model. So basically what we're going to do here is we're going to go into the AutoML menu, and once we're there, we're going to actually look at our experiment. So we click on the name of our experiment there that we want to check. So that was a previously run experiment. So then I can see what the listing of the models is. So I can scroll down and look at the list. And then say I want to choose one of the models. This is the random forest model. So I'm going to just click on rename. I rename that model name. And then by giving it a model, a specific name, when I say OK, now the model is renamed. So now that model, instead of having a randomly assigned name, is going to have the name that we want to use. So now we can actually take that model name with that model, and then we can reuse it. Now let's check if that model is explicitly in our models. We go into the Oml Models, and then we can basically check, type something like auto in the search, and we can see that our model is right there. Right, that's the first one on top. So now the model is under user models, so we're going to be able to score with it, right? So what we can do is we can go back home and then go into our Scratchpad. So the Scratchpad will give you capabilities for scoring the models just by typing, any SQL. So I basically took this SQL, very simple, where I'm saying, I want to see customer ID, I want to see prediction, and I want to see the prediction probability, and I want to see also all the rest of the table, right? All the other columns. So when I run this, basically I'm going to have a very quick component running, a very quick scoring, right? That shows me the results. So I can see that I have a customer ID, will buy or will not buy, and probability. If the probability is larger than 0.5, the customer will buy it. If the probability is lower than 0.5, then the customer will not buy the product, right, in this case. So now we have, from Automl Ui, the deployment into auto-generation of notebooks. So let's take a look how that works. Basically, we're going to go back to AutoML, and we're going to go back to the experiment. So opening up the experiment, we now see the models that we had there, including that first one that had that rename, right? So we're going to actually select that line, and by selecting that line, we can click on the Create Notebooks. So now we give that notebook a name, and we say OK. So what now happened was the Automl Ui generated a whole notebook for us with the entire construction of that model. So we're going to go there, we click on Notebooks, and now we see the listing of notebooks. We can then search for the one that we gave it just a name, And then we can now open that notebook up. So OML is going to start and initialize a notebook for us with that name and bring it over. So basically what we're going to do now is just going to run everything. We're going to run all paragraphs so that we can preview the results. And at the top you have the metadata about the model, so it tells you, where that model came from, what date it was executed, things along those lines. And then it gets all the proxy for the data. So that's the input data set. What is the data that's going to go into the model, right? So it creates a proxy to that data, and we can preview it like this. And then we have basically the preparation of that data, right? So we split into X and the Y as required by Python. But now we see the model details, and these are the details optimized by Automl Ui, the best model that it found. And now in the model details, once the model is run, we can just check and scroll down and see information about the model, the global statistics, attributes used, right, random forest. And in this case, because it's random forest, it shows you the attribute name and the attribute capability, so you can see the attribute importance of the columns there. So for scoring, we can just easily use the same data just as an example. And when we do that, we can actually have that capability of the balanced accuracy. So we can run that and compare that accuracy that we got with that data set. So if we had a different data set, we could do that. And in here also, you can just run a simple code that was going to preview every customer information. And then all the way to the back, you're going to have, again, your columns, prediction and the probability. In this case, it's a little different. The probability is the probability of that prediction. So if you have a probability of 1 for no, that means the guy is really not going to buy that, right? So deployment to OML services then. So how does AutoML does that? So in AutoML, then you're going to go into now, again, into our experiments. So the same way we go to AutoML, we go and open up our experiment, and we're going to select the model again. But now we're going to then click on the deployment. So when you click on the deployment button, all you have to do is you got to give it a name. You can just leave it as is. You need to give it a unique URI and a unique version for the model. So you can say, okay, that's the OML models, and then I'll want the model to be shared so other people can use it. And then the model has been deployed. So that's just an alert there. So basically the model is available now in OML Services via REST. You can do the same thing from within the OML Models menu. So let's take a look at how that looks. If you go into OML Models menu, then in there, basically what you're going to see is that you're going to see every model that has been deployed, right? So if you sort by date, you can see one of the latest models we have is, for example, support vector machine that we were testing, right? And the target was the same, affinity card. So let's deploy that model to make it different than the other one. So we now give it a nicer name, right? Because that horrible name is the random name that it gets assigned automatically by OML. And we give it a unique URI again, model version, and we get it into exactly that, right? So it gets deployed again. So now it's available in OML Services for REST, right? So the OML Services then is the key for scoring models in real time, right? And that's going to happen for the models that you deployed, right? We just deployed 2 different models. So for those 2 different models, this is the route. So once the data scientist is using the components there, right, he can deploy the model to OML Services like we just did. But there are also options for OCI data science users or open source environment users that are deploying models into ONNX format. So OML Services can also take those ONNX files and then add them and deploy them, right, for scoring in real time. So at that point, the application developer is going to be using REST, right, to call those models. So if we look into this quick demo, basically what we're showing you is that you have a few components to call that model. The first one is a URL. That's depending on your data center. The second one is going to be the model URI, the name that we just gave the models, right? And then finally, we need a bearer token that we need to request. On the right, you see a little animation, but we're going to see an entire demo of that process. So first things first, let's verify that those two models were deployed, right? So if we go to models then, in OML models, we go into the deployment tab. And deployments is a little bit different now. Not all models that are in user models were deployed. So we sort by deployment date, and we can see that actually both models that we just deployed are there, right? The prediction affinity AutoML RF and the support vector machine linear model as well. And now if we click on the URI of them on the right, we can see the entire Open API. So that gives you the actual URL to connect, right, to the model. But then it gives you all the information about the model, the inputs, right? So what are the attributes that this model is using as an input? And then if you keep scrolling down, you see the attributes and the types. And you're going to also see the output, right? So for the output, we expect probabilities, we have the labels, and we have that kind of information all there. So with that, the model is basically, deployed into REST, right, into the Oml services, and they're ready to be scored, right? So now if we launch something like a Postman, right, in desktop. So I'm launching Postman here in my desktop, and when I get there, the first things that I mentioned before, we need to get a token, right? So we're going to pass our identity from the Oracle Autonomous Database, and then we get a token back. So it's very simple. And I stored that token as a variable, as an environment variable, so that I can reuse it very easily. So now let's take a look at the metadata from that deployment, right? So this is the same thing we looked at right now from the other perspective, but you can see that I'm explicitly putting the model name in there in the call so that we know exactly which one it is, right? So then when we do that, we see again the same information, and this is the results, right? Deployment details of that model. Something similar we just saw. So we see the input attributes, and we're going to see the output attributes and things along those lines. And then to make it easier, we can visualize them. So there's a processing that I did for JSON, so we can easily see the output there. So it makes it easier for us to read. But then you can see we have all of those details, right, about the model, the shared, when it was shared or not, URI, and things along those lines, right? And then if you scroll down, you see the output attributes, right? You see the metadata for the label, yes or no. So that's what the model is returning to you. And then these are the input attributes, right, that are expected. So let's score that model, right? So for scoring, the only difference we're going to see is we're going to have to add a /score to the URI, and then we have a body that we need to send the data. So in this case, your application would be sending the data for the scoring in real time. And then when I send the data, basically the result is going to be the score. Right, so you get the score, the result is in JSON format, you're going to have a label of no, and in this case there's a 98 probability that the customer is not going to buy your product. And then there's a yes, right, with only 1% probability. But then the model details, which is the most important thing that OML does, is it gives you the weights on the attributes that contribute to that decision by the model. So basically the probability of 98% that the guy is not going to buy was actually based on their bank funds, profession, gender, and number of transactions, and ATM, and things along those lines. And those were the weights, okay? We can repeat that for the other model, right, for the SVM model. And when we run that, we can see that this is a different probability, right, because it's a different model using different components. And we have a different weights as well. So the weights for the decision are based on household size instead, right? So there are also an important thing in OML is, that is resilient, right, to any problems in data. So I remove 3 columns here, I run it again, and it actually gives me back the probabilities anyway. Okay, so we are completely resilient to data breakage, problem in your application did not have data, there was any issues, we get that data back for you. So where to go from here? So basically the idea is there are lots of different places where you can learn more about all of these technologies and capabilities. You can check out the live labs. We have live labs in SQL and a brand new live labs in Python for OML for Pi. You have also OML notebooks, so we have more than 70 different examples in the templates there. So you can check out everything from model building and scoring and data preparation and data cleansing and time series analysis. So anything that you're thinking about in terms of different types of processes and using different algorithms, they're all going to be there. And then we have a GitHub repository with a lot of data. So we have sample data sets, sample code for different database releases since 18. And we have the OML office hours, where we bring you news every week. So we have different technologies being presented to you, use cases, we have best practices. So there's a lot of great things that you can do there. So if you want to subscribe to our Oracle Machine Learning office hours, it's a great spot to learn a lot. So finally, again, the content on GitHub. So including all of these different demonstrations that I did today related to things like even the Postman. So we have a Postman collections there for Oml Services. And we have definitely a lot of code there. We have Python code and we have R code as well. We have Oml for Spark code. So we have lots and lots of demos there that are interesting for you guys. So that's it for today. Thank you very much for joining us, and thank you for attending this session. I hope you guys have a great day.